I'd like to share my dump load control unit that I put together. I have an opportunity to reuse the timer circuit that I've had. This timer is the Auber instruments I've mentioned before in some videos that can perform a lot of tasks. I originally bought that as a tachometer with a Hall effect sensor on my 10-foot axial flux that I never put up, but in the meantime I've been reusing that, and right now I have it set up as a trigger, countdown relay trigger. And let's see this light. When I hit reset here, light comes on and it's going to count down from 30 seconds down, and after that the light will shut off, and the light is plugged into that outlet there. So that outlet is being controlled by a contactor, which is being controlled by the timer circuit here, and the timer circuit is being controlled by a ghurd, the ghurd controller as they call it. So I can give you a peek inside. The DC voltage is being sensed up here. I just have the panel open and clipped in there as I'm building this and testing it. And here we have it. There is the ghurd controller. Basic voltage differential sensing circuit. You set the threshold. I have it set to 29.7, 29.8 volts because I have a 24 volt system. They're Trojan T105 batteries. And the control is it's controlled by this FET here, which is biased, and I have the drain and the source connected to the reset pin of the timer here, which starts the countdown. When the countdown starts, the internal relay of this timer throws 24 volts DC to this contactor here, which I put that Shakti diode in there as a flyback to prevent spikes from getting back into the system. I don't know if that's necessary or not, but figured I'm playing safety there. That contactor in turn throws the internal relay and completes this oops, where am I? There, completes the AC circuit here. I ran AC out of the inverter, comes through the net ground side. The negative side is connected here. The hot side goes through the contactor in the normally open contact, comes out of the contactor and goes back to that switch. So when the contactor closes, it completes that AC circuit and makes that outlet hot. And when that outlet's hot, it'll energize whatever's plugged into it. Right now I only have a light bulb for testing purposes. I did see the light bulb go off earlier, so I might need to add a little higher wattage to burn off some power if I enter that danger zone there. Otherwise I'm going to be bubbling and equalizing my batteries unintentionally. The dump active light will illuminate when it reaches that voltage. If the dump load brings the voltage down immediately, that dump active light will turn off until the counter reaches 0. If it gets another spike from the ghurd controller, the dump active light will come back on, and that circuit will be reset. So as it's counting down, it'll actually be reset just like that, and it'll keep triggering it and keep that dump load on until I notice my light's not coming on, and I think it's because of the contactor switch, until the voltage is off. So let me make sure my AC is good here. Oh, it looks like it is thrown. Okay, I got another issue here. So, oh, okay, I had the light bulb turned off. That's why. So anyway, if I keep hitting reset, it'll keep that light on So the dump controller could keep spiking that over and over and keeping that bad boy on until it's satisfied. Not sure what else more I could tell you here. The windmill, my Anern, not as happy with it as I thought I'd be, but everything I read said it's not all that anyway, even though it claims 1,000 watts. It's most I've seen out of it so far, when I was measuring it, was about 8 amps, which isn't a whole lot. Okay, I just shut off. So anyway, that's my dump load circuit. It's just about complete. Thanks for watching.